Okay, good afternoon.
Good afternoon, sir.
Yes, am I audible?
Yes, sir, you are audible, sir.
Okay, so just wait 1 minute, then I will start. Okay, so good afternoon, all of you. So we will start. So previous classes we have discussed in our advanced control system. This is a jet transform. Okay. So am I audible, Subhasis?
Yes, sir, you are audible, sir.
Okay, thank you. So previous classes we have access in our physical mode in our classroom. We have discussed the definition of jet transform, what is the basic properties of jet transform, and we have explained one by one different types of function. That is the unit step functions, parabolic functions, ramp functions, exponential functions. There are lots of functions we have to discuss in our previous class. So in this regard, we have uh, jet transform. There are many of properties. Okay, so today we will discuss the different properties of the jet transform. So I am sharing my screen. My whiteboard is visible.
Yes, sir.
Okay. So first of all, I just recall the previous one. Then we will continue. Okay. So what is jet transform? First you have to tell what is the jet transform. Any idea? Anyone? What is jet transform? Okay, so in our mathematics, when you have to learn in your first year or second year, first sem, so you have learned different mathematical expressions. So one of them that is the jet transform. So in our mathematics and also signal processing, okay. So this jet transform, it is basically converts discrete time signals. So in your advanced control system, you know that there are discrete, we have considered here discrete control system. Okay, that is a discrete time signal. So in mathematics and signal processing, in mathematics and signal processing, the jet transform converts a discrete time signal which is a sequence of real or complex numbers. Complex numbers into a complex frequency domain. Complex frequency domain. And this complex frequency domain we have considered here. This is also called jet domain, or sometimes it is also called jet plane. Okay, representation. So I am recall once again what is jet transform. So in our mathematics, in and also signal processing, that means you have to learn, that is your digital signal processing. There are two types of signals we have to consider here. Okay, that is, one is analog signal, another one is the digital, that is a discrete control signal. So in our advanced advanced control system, we will consider for the discrete time control system. So in this discrete control system and also mathematics, this jet transform, it is basically convert a discrete time signals which is sequence of the real number or complex number into a complex frequency domain. That means this domain, this frequency domain, it is basically called the jet domain or jet plane. Okay, so you know that we have discussed in our previous classes, this is a jet transform, and we will discuss that is a sampling period. This sampling period, that means first of zero, that means you have to consider here, this is a mathematical one diagram. So first, second, third one, fourth one, and so on. This process is continuing. You know that that is a zero starting point, first t, then 2t, then 3t, then 4t, and so on. So this is the basically timing gap. So this timing gap you have to know, this is basically same timing gap. So using this sampling period, we have to convert the signals, jet transform signals or discrete timing signals into a sequence of the, either it is also real part, another one is the complex part. This is basically called the jet transform. Okay, is it okay, all of you? Please respond, anyone, is it okay or not?
Yes, sir.
Okay, okay, thank you. So now you have to know what is the basic property. So in our classifications, we have to classify this jet transform into basically two categories. One is the bilateral jet transform, another one is the unilateral. That means one-sided, another one is the two-sided. You know that I've given in the previous classes. So number one is the one-sided jet transform method, and this is basically called the unilateral. This is basically called unilateral jet transform. Another one, it is basically called two-sided jet transform method, and it is basically called bilateral. So please remember these two terms also, unilateral and bilateral. In your question paper, sometimes it is this unilateral and bilateral, it is also used. So in our discrete control system, we have only considered for the one-sided jet transform method, that is the unilateral jet transform method. So now, what is one-sided jet transform method and what is two-sided jet transform method? Any idea, anyone? So first, we have to consider the unilateral jet transform. That means it is also called the one-sided jet transform. So the function is, that is x of z. This is equals to the z transform of function is x of n, and we have to written this equation, that is a jet transform. You know that summation of n is equal to 0 to infinite x of n into z to the power minus. Okay, so this is the basically called the one-sided jet transform. Okay, so this is basically uses in our signal processing method. Okay, so in our signal processing method, this definition, it can be used for evaluate the jet transform of the unit pulse response. Okay, so remember these things. This is basically uses in unit impulse response of a discrete time causal system or control system. Okay, so this is basically called the unilateral or one-sided jet transform. And another one, you know that this is the bilateral or two-sided. Bilateral or two-sided. So what is the range of this unilateral? You know that is the range is in one-sided or unilateral, that is 0 to infinite. So that's why we have to use this, that is n equals to range is 0 to infinite. But in our two-sided or bilateral jet transform, here the range is, you know that, minus infinite to the plus infinite. Okay, so what is the examples? What is the examples of this bilateral jet transform method? The equation is x of z. This is equals to jet transform of a function x of n. This is, we have to represent this equation summation of, you know that is n equal to minus infinite to the plus infinite x of n g to the power minus n. Okay, so here this n is basically integer part. Okay, this n, where n is integer part. Okay, and this z, it is basically for the complex numbers. Okay, So complex number. So when this complex number, so Z is the basically uses complex number. So the response, one complex number, we have to express, that is Z equals to A. This is the A, e to the power j phi. So this is equals to the function. You know that we have explained in our previous class that our Z transform table. So you have to follow this table, that is A into cos phi plus j sin phi. Okay, so here A is the basically magnitude of the Z, and this J is the basically, you know that, imaginary part or imaginary unit. Okay, and phi is the basically complex argument. Okay, so please remember this thing. This is basically two-sided or bilateral Z transform method. Okay, is it clear, all of you? No one is respond, so this is very bad.
Yes, sir.
Yes. So everyone, please respond, because I am not known you are understand or not understand. Okay, so this part, it is basically important for your types of different types of the Z transform. So next, we have to consider there are different properties. Okay, so these properties, it is very important. So different types of properties are available. Properties of Z transform. There are many types of properties available. Number one, first, multiplication by a constant. By a constant. So in this case, this xz is basically Z transform of, we know that Z transform of xt. So that means if xz is the Z transform of xt, then we have to written this equation. You know that Z transform of A of xt, that is A is constant term. So A Z transform of function is given, that is xt. You know that. So now you have to written this is the xt. That is the equation A of xz. Okay, so here A is basically constant term. Okay, where A is constant. So now we have to prove this equation. This is the basically Z of axt is equal to A of xz. So now we have to apply the Z transform. So function is Z of axt. So we have to apply the Z transform. So this is basically one-sided. So range is, you know that, is equal to 0 to infinite. Function is A of x into kt, z to the power minus k. Now you have to put the value of different k is equal to 0 to infinite, and A is the constant term. So constant term, it is right in the other side, that is the A summation of k is equal to 0 to infinite x, function is x kt, you know that, and into z to the power minus k. Now A is constant term. Now we have to put the value of 0. So here you can put 0, then you can put it is also 0, then you can put it is equal to 1, z to the power minus 1. So there are different values are coming, but the general function that is the x of z. This is the basically x of z. It is a function of this one, that is x kt into z to the power minus k. We have to return this part into the x of z, because this is a one-sided function. You have to put the value of different. First, you have to start k is equal to 0, then k is equal to 1, and so on. So basically, function is x of z. So now you can see this is the basically proved z of x is equal to ax. Okay, so this is basically properties of the one Z transform method, multiplication by a constant. So which is constant part? A is the constant. Is it clear?
Yes, sir.
Okay. Next, number 2, linearity property. What is linearity property? In your semester exam, questions are coming. Write the linearity property of Z transform method. So this type of question is coming in your exam. So number 2, linearity. So here are lots of properties are available. So we have discussed some of them, that is the important properties. Okay. So first one is multiplication. Number 2 is linearity of Z transform. So linearity means, so in our Z transform method, so we have to use different functions, that is the x of z or y of z. There are lots of functions we have to apply. So in the Z transform process, there are important properties. It is basically linearity. That means we have to take the two functions. One is the f of k, another we have to take g of k. So there are two types of functions represent here, f of k and g of k. Okay, so these are Z transformable. And alpha and beta are the scalar. Then the function of xk formed by the linear combinations, formed by a linear combination. So the function is written here, that is x of k. This is equal to alpha. Sorry, this is 1 minute. This is the alpha of f of k, first function, then beta into second function, that is the gk. Okay, so when you have to put the Z transform into these equations, so function is coming. So the Z transform that is x of z is equal to alpha f of z plus beta g of z. Okay, so this is basically the Z transform of the previous this function. So where f of z and g of z are the Z transform of f of k and G of K. Okay. So now you have to put the linearity property. So the linearity property. So please don't write anyone in the slide. Please don't write anyone, please. So linearity property can be proved by referring to equation. Which equation? मैं पहले दिन से मैं दो फंक्शन में पहले क्लास से स्टार्टिंग से बोल रहा हूँ, वो दो इक्वेशन आप लोगों को मतलब याद रखना पड़ेगा. सो इक्वेशन टू क्या था? anyone please tell. That is equation 2. It is coming x of z. This is equal to z transform of x of k, and we have to written this equation summation of k is equal to 0 to infinite x of k z to the power minus k. So these equations, it is very important. And another one, it is also when the kt is coming. So these two types of equation, it is basically uses again and again. So now we have to apply the linearity property to prove this equation for the linearity of the Z transform. Okay. So we go the next slide. So in the equation previous one, so we have to apply. This is the x of z. This is equal to z transform of function is x of k. So we have written this equation z transform of alpha f of k plus beta g of k. Okay, you know that this equation previously we have to written. So now you have to put the value, that is summation of k is equal to 0 to infinite. Function is alpha f of k plus beta g of k into z to the power minus. So now you know that this alpha and this beta, it is basically constant term. So in our Z transform method, constant term, this is not convertible. So the constant term we have to written in the outer side, that is the alpha into summation of k is equal to 0 to infinite f of k z to the power minus k. This is the one function. Another one, this one, this is beta into summation of k is equal to 0 to infinite, that is function is gk into z to the power minus k. Is it okay? Is
Yes,
it okay
sir.
or not? Yes. So anyone please tell me what is this is basically first term, this is another second part. So this is the one rules we have to apply. What is the rule? Into this we have to apply into these equations. What is the rule? This is basically shifting rule 15, because if you know that this is the one complete function, then we have to convert this equation using the after shifting rule. This is basically first term, another one is the second term. So this rules, it is called the shifting rule of our Z transform. Now you can easily convert. This is the alpha into Z transform of, that is the f of k plus beta into Z transform of G into K. Now you know what is the Z transform of Fk. Previous slide you have to go. Previous slide यहाँ पे देखो Z transform of this term, that is alpha into F of Z plus beta into G of Z. So you have to apply this value into this equation. So we have to return alpha into F of Z plus beta into G. Okay, so this is basically so this is the basically called the linearity property. Okay, so this is the linearity property. So x of z, this is equals to alpha into fz plus beta into gz. This is basically gz. Okay, gz. Is it clear? So you have to prove this equation using the linearity property. Is it clear or not? No one is answering. Komal, is it clear? Manisha?
सर ये नोट्स सब हम लोग को प्रोवाइड किया जाएगा.
Sorry?
सर नोट्स हम लोग को प्रोवाइड किया जाएगा जो क्लास में हो रहा है.
हाँ, ये तो किया जाएगा, इसके लिए कोई टेंशन नहीं है. पूरा जो क्लास नोट अभी मैं लिख रहा हूँ व्हाइट बोर्ड में, ये आप लोगों का गूगल क्लासरूम पोर्टल में जाएगा. इसके अगर मतलब किताब में जो आप लोग पढ़ते हो उसको भी मैं हैंड रिटन नोट या कोई प्रिंटेड नोट, कोई भी डाउनलोड नोट जो होगा, I can apply this in your Google Classroom portal. So everyone please join the Google Classroom portal. So okay, so day by day we have to upload it every class notes, and this is also uploaded in your Google Classroom. So everyone please write your own name and roll number in the chat box also. This is for the attendance purpose. Okay. So okay, so we can go next, another one. Number 3, multiplication of the polynomial functions. Number 3 is the multiplication by one polynomial equation. You know that we have to apply previous classes for the how to polynomial functions solve in our Z transform method. Okay, so this AK it is called the polynomial function. So now if x of z is the Z transform, Pranav is present. Pranav, please respond me, Pranav.
Yes, sir.
So please you take a screenshot in the total participant list, and after ending the class you send me my personal WhatsApp for this screenshot. This is basically recorded attendance for day by day. Is it okay?
Okay, sir.
And
Yes.
it is also one page, only one page. Okay, not multiple pages.
Okay, sir.
Okay. So now we have to apply the multiplication rules for the polynomial functions. So this xz is the Z transform of the xk, then the Z transform of polynomial function, that is the a to the power k into xk, can be given by x a to the power inverse into z. So now the function is z of a to the power k into xk. So the answer is, that is the x of a inverse z. Okay. So now we have to prove this equation. The equation is given, that is z of a to the power k x of k. This is equal to summation of, you know that is 0 to infinite. Function is a to the power k x of, this is the basically function, a to the power k x to the power k into z to the power minus. So you have to put the value, that is k is equal to 0 to infinite. This is x of k and a inverse z to the power minus. Okay, so now you have to put different value of k, that is k is equal to 0, 1, 2, 3 to the plus infinite range. So the value is changes. That means this value it is also changes, because you have to put the value of different k into this position and into this position. And x is basically the constant term. So x into function is coming a inverse z. So this is basically called the one polynomial function using the multiplication rules. What is the multiplication? Here x multiplied by polynomial function a to the power minus 1. Okay, so this is basically one properties of the multiplication by a to the power. Is it clear? Next, previous class I am given one home task. Do you remember? तो जो होम टास्क दिए थे वो हुआ था? Anyone please respond me. एक क्लास में, एक मतलब फिजिकल क्लास में हम लोग एक एग्जांपल दिए थे होम टास्क के लिए. Find the z transform, क्वेश्चन था find the z transform of unit step functions that are delayed by 1 sampling period and 4 sampling period. I'm written the equations. This is basically one example. Find the z transform. Everyone write your own name and roll number into the chat box of unit step function that are delayed by, sorry, this is the find, by 1 sampling period and 4 sampling period. Okay, so आपको ये क्वेश्चन दिया गया है. So question is find the z transform of the unit step function. You know the unit step function. Previous classes we solved the different unit step functions. So this unit step functions, condition is given here, the time delay. Okay, time delay, t time delay. It is first is 1 sampling period, another one is a 4 sampling period. So ये क्वेश्चन आप लोगों को दिया गया था होम टास्क के लिए. कौन कौन किया है? So please respond me. क्वेश्चन इज वेरी इजी. देखो मैं तो मतलब समझ में आ गया, कोई नहीं सॉल्व किया है. So first two you have to solve for the 1 sampling period, that is z of 1 into t minus capital T. Okay, so the function is z transform of z to the power minus 1 into z to the power z transform of 1 of t. This one it is used for the 1 sampling method or 1 sampling period, delayed by the 1 sampling period. So function is given